this module, we will learn correlation. That is introduction to correlation and types of correlation. In the real life, we come across related variables. That is income and expenditure, income tax rate and income, number of dependents and household expenses. So many related variables, or advertisement expenses and sales. So these are called the related variables. So the advantage is change in one value may change other value also. So if you know one value, we can predict the other value. That is what we are trying to do with the correlation coefficient. So it's extensively used in business studies, research studies, all that we are using this. So when two variables are related, we are calling it as correlated variables or related variables. Examples are age of husband and wife, price and demand, advertisement expenses and sales, all this. So the statistical tool used to study the relationship between two or more variables, it's called the correlation. Now, measure of correlation is called the correlation coefficient. So correlation coefficient will tell us in one figure the direction and degree of correlation. Now, what do you mean by that? That is, correlation value will be always either plus or minus. Plus meaning it is positive correlation and minus meaning it's negative correlation. Positive correlation meaning variables are moving in the same direction. If advertisement expenses are increasing, sales is also increasing. Whereas negative correlation meaning number of dependents are increasing, then the savings is decreasing. So that is, both the variables are going in the opposite direction. And one value also we will get. So one sign will be there and one value. So one figure will tell whether it's positive correlation or negative correlation and what is the amount of variation. So that is the advantage. Now correlation is used to study the closeness between related variables. So the examples, advertisement and sales, income and savings, number of dependents and household expenses, these are all the related variables. Now if you see the definition for correlation, A.M. Tuttle has defined correlation as an analysis of the correlation of two or more variables is usually called correlation. So always you have to remember that two variables will be there to measure the correlation. Now uses of correlation coefficient in measuring the relationship between variables. Examples, income and expenditure, price and demand, income and savings. All these are examples. Now if it's estimated that one variable is related, then we can predict the value of other variable. That is an important thing. If price is this much, but expenses are unknown, so we can predict the value. That is what we are going to do with the correlation coefficient. Now correlation coefficient is also used in studying the economic behavior. Government will be using this extensively because they have to take the decisions or policy decisions or policy changes. They will be using correlation coefficient. Examples, impact of demonetization, impact of inflation. All this they are using to study the economic behavior. Now correlation is widely used in social science studies. Now examples are relationship between smoking and lung cancer, number of road accidents and vehicle sales. Now types of correlation, we are dividing into three: positive and negative, simple, partial and multiple, and linear and non-linear. So positive and negative correlation. Positive and negative correlation is decided based on the direction of change of variables. I told you when we are computing the value also, we are getting plus sign or minus sign and one value. So that is, whether it's positive or negative, we can understand from the computed value. If both variables are moving in the same direction, that is, if one variable is increasing, other variable is also increasing, then the average is said to be positive correlation. Whereas if one variable is decreasing, other variable is increasing, then it is said to be negative correlation. If one variable is increasing, other variable is decreasing, or vice versa. So we have to decide whether it's positive correlation or negative correlation, and it's very important for interpreting the data also. Now, I am giving an example for positive correlation and negative correlation. The first set of data is positive correlation. You can see that values of X, 10, 15, 20, 25 and 30. 5 is the increase. The other set of values Y, 15, 25, 35, 45 and 55. 10 is the increase. So one set is increasing, other set is also increasing. That meaning it's positive correlation. Whereas the second set, it's negative correlation because the X values, you can see that 10, 20, 30, 40 and 50. It's increasing. Whereas Y values 40, 30, 20, 10 and 5. It's decreasing. So one is increasing, one is decreasing. Then it's a negative correlation. Now we are coming to the second division, that is simple, partial and multiple correlation. So this distinction is based on how many variables you are studying. So that meaning if you are studying only two variables, it is called simple correlation. Income and expenses, it's an example of simple correlation. Or savings and income tax rate, it's simple correlation. Only two variables are studied. But if you are studying three or more variables, then it is called multiple variation. So the multiple variation relationship between savings and its impact on number of dependents, income, age, income tax rate. So more than three variables, then it is multiple correlation. Now we have to see what is partial correlation. In partial correlation, we study more than two variables, because two variables we are calling it a simple correlation. More than two variables we are studying to come under the category of partial correlation. But you have to remember that consider only two variables, and other variables we will consider that these are not influencing each other. Those values we are taking, we are assuming that these are constant. There will not be any change. So the effect of other influencing variables will be kept constant. So if I'll give you an example, it will be more clear. If we study the production of rice, taking only yield and rainfall, but we see that temperature is kept constant. There is no variation in the temperature. That meaning temperature is constant. So by considering only two variables, that is yield and rainfall, on the effect of production of rice, then it is called partial correlation. More than two variables are studied. Other variables, any number of variables we are considering, then all other variables we are saying that it's constant, there is no change in the values. Now we have to come to the third classification, that is linear and non-linear correlation. Non-linear correlation is also known as curvilinear. So you can see that when we plot that in a graph, it will form like a curve. So this distinction is based on constancy of the ratio of change between the variables. So if change in one variable tends to bear a constant ratio of change of the other variable, then it is correlation is said to be linear. So if you see that values of x and values of y, there's constant change. Values of x 10, 20, 30, 40 and 50. 10 is the increase. Values of y 30, 60, 90, 120 and 150. 30 is the increase. X values are increasing at 10 each. Y values are increasing at 30. So this is constant change for both the variables. So it is called linear correlation. If you plot these values in a graph, you can see that this will be a straight line it will form. So that is the graphical representation of linear correlation. But non-linear correlation, you have to remember that if the amount of change in one variable is not having a same constant change with the other variable, then it is called non-linear correlation. Though this is the definition, always you can see that almost all the cases in social science or in real life, we can see that it's a non-linear relationship only between the variables. But the computation is very difficult for non-linear correlation. So non-linear correlation, we assume that variables are moving in the opposite direction. For our computation of correlation, we always assume that there is a linear correlation between the variables, because the computation is simple. Non-linear computation, correlation computation is very, very difficult. If I'll give you an example, if you double the amount of rainfall, the production of rice may not be doubled. There will be always change in that. So that is why real life always we see non-linear correlation. But for computation purpose, we assume that all correlation, there is a linear relationship existing between the variables. Now we will see that how this graphically it is represented. So I told you it will form like a curve only. So that is why the graphical representation of non-linear correlation, if you plot, you can see that this will be the representation. Whereas if you see that linear correlation, it will be a straight line. Whereas this will be forming a curve. That is why curvilinear correlation also. That is the other name used for non-linear correlation. So this is what I want to explain in this module. Thank you.